so with a background on differentiation, we will now do differential equation. Okay, so a equation of the form, like say, let me write a equation dy by dx. Okay, dy by dx is equal to gx. Okay, so gx is nothing but a function of x. So this is, let us say, equation 1. So a equation of this form is known as a differential equation. Okay. Okay. So this this why do we need to study differential equation? Because this concept this concept is used in physics, chemistry, biology, anthropology, geology, economics, everywhere. This concept of differential equation is applied in all these subjects. Okay. Hence, in-depth study of differential equation is of prime importance in more modern scientific investigations. Okay. So we are already familiar with different these equations. Let us say this is what and all we have already studied: x square minus 3x plus 3. So what it is? This is a polynomial.
Yeah.
Okay. So you know what is a polynomial? So it will have some coefficients like constant coefficients and some power of one particular variable.
Yeah.
So it is not a mix of x and y. Okay. So this is a polynomial. So it has some coefficient. So you might have studied, no, like say a0 x to the
ax
power.
square plus bx plus c. That is quadratic equation.
That is polynomial. In general, what is a polynomial? Polynomial a0xn then a1 x to the power n minus 1 or a2 x to the
General
power n,
form, yeah.
x to the power n minus 2. So this
Depends
power,
on what your n is.
and then finally it will become x to the power 0.
Zero.
This is a constant. So is equal to 0 or whatever you write. So this is nothing but a polynomial, right?
Yeah.
It will be having one x, no, a combination of x and y, and it will have some constant as coefficient. So this is a polynomial. Then sin x plus cos x is equal to 0. So this is a trigonometric kind of. Then you have x plus y. Okay, so x plus y, you know, this is a equation of a straight line.
Yeah.
Right. So you have x and y both, but in polynomial only you have x.
Yeah.
And these are some trigonometric
Metric.
functions. So you are familiar with these equations. Okay. And then let us consider, say, equation number 1, 2, 3. Okay. So we are already familiar with one is a straight line, one is a trigonometric function, and another is a polynomial. So let us write a equation x dy by dx plus y is equal to 0. So this equation, equation 1, 2, 3, what is telling? Equation 1, 2, 3 involve independent and or dependent variables only. Okay, involve independent variable. But equation 4 involves variable as well as derivative of dependent variable. Okay, so it involves variable also
Derivative
the derivative of variable. Okay, so such an equation is called a differential equation. So a equation involving derivative of a variable, an equation involving derivative of a variable with respect to independent variable. So an equation containing derivative of a variable with respect to independent variable. So an equation containing derivative of a variable with respect to independent variable. Here independent variable is x. Okay. independent variable is called differential equation, right?
Yeah.
Okay. So now you got the definition of differential equation. Okay. So a differential equation derivative of differential with respect to only one independent variable is called. There are two types of differential equation. We are not. There is one is called ordinary differential equation, and another is called partial differential equation. Okay. Involving derivative of dependent variable with respect to one independent variable. So here derivative with
Only
respect to
x.
one, with
Only.
respect to only one, is
X
called
is
ordinary
that.
differential equation. Of course, there are differential equations involving derivative with respect to more than one independent variable.
Understood.
Okay.
And then now
Hmm.
different and derivative of y will also be.
So those where you have derivative with respect to more than, so what is partial differential equation? Derivative if it contains derivative with respect to more than one independent variable. Then it will be called as partial differential equation. Anyway, that is not in our scope. So, what is our scope? This is called ODE, ordinary differential equation. Another is partial differential. So, our scope is until 12th is ordinary differential equation. In plus 3 or BSc, they do, or in engineering, we do partial differential equation. Hmm. So, take a picture of this, then we'll go to some examples. Okay. So, a equation containing derivative of the dependent variable with respect to independent variable is called a differential equation. If it contains, if the derivative with respect to not a single independent variable but more than one independent variable, then it is a partial differential equation. Then consider the following differential equation. Let us take some example. So dy by dx is equal to e to the power x. Okay. So this is a differential equation. Similarly, d square y by dx square, d square y by dx square plus y is equal to 0. This is also a differential equation. d q y by dx cube. That means you are differentiating it 3 times, right? Plus x square into d square y by dx square, d square y by dx square whole cube. Okay. This is 0.
Yeah, that ordered cube.
So the equation 6, 7 and 8, so let us say this is 6, 7, 8. So the equation 6, 7 and 8 involve the highest derivative of first, second and third order respectively. Therefore, so what is the order of a differential equation? Okay. So here you can see this is first order. Okay. Means you are differentiating it once. Okay. So here you have one differential term and that is first order only. You have one differential term, but here it is
Second order.
derived twice. So this is a second order. Okay, this is a second order differential equation, right? This one, and here you can see it contains derivatives, but this is second order, this is third order. So the highest order that is present
That
is
is
called
like order, and power
order
of power of that is taken as degree.
So this is third order differential equation. Differential equation.
Its degree is 1.
Okay, so yeah, so here its degree is 1. So the power of the highest order is the degree. Okay, so you need not confuse. This is the
No.
second order, that power
You
is
should not
not
take
1.
that.
So here its order is 1 and degree order is 3, degree is 1. Okay,
Yeah.
degree is 1. And there are some more equations like say dqy by dxq. Okay, so so these things you can find out the order and degree.
Yeah.
Okay, but there is one equation where you cannot find
If it's
out
associated with e power x or sin x, the order form, then it is not
yeah.
defined.
So dy by dx plus sin dy by dx. So here you cannot find
It's
the
not defined.
so
Degree.
here the yeah. So this degree of
Degree is not defined.
so degree of such a differential equation is not defined. Okay.
So order is 1.
So here, why is it? Because these two are all polynomials. Okay, these are all polynomials, whereas this is not a polynomial. Okay, so because
it's a half.
sorry, these are polynomials. Sorry, these are all polynomials, but this is not a polynomial. Okay, so in a polynomial, this will have only a constant. So you are taking sine of this term. So it is not a polynomial.
Yeah.
But if it is only say dy by dx and with multiplied by some constant, then it will be a polynomial. But you are taking sine of a derivative, so that's why it is not a polynomial.
Understood.
So it is not. You cannot find the degree of such a differential equation.
Yeah.
So degree of such a equation, such a polynomial, such a differential equation is not defined. Okay. So there are many examples how to find the order and degree. So let us say one example is so dy by dx minus cos x is equal to 0. Okay, so here its order is 1 and degree is 1, right?
Yeah.
And let us say yeah, so y triple dash. Okay, that is three times derivative, then y square plus ex is equal to 0. So this is my derivative. So you can write it as dq,
order is 3,
dq y by
degree is 1.
dx cube plus y square plus ex is equal to 0, right? So in this case, its order is 1, degree also is 1, right? Degree is the
Order is not 1.
sorry, order is 3.
Order is 3,
Order
degree
is 3,
1.
degree is 1. Sorry. Okay. Order is 3, degree is 1. Okay. Then there is another example like xy d square y by dx square plus y square plus e to the power x or something. This is equal to 0. So if this is the case, then the highest order is this, right? Highest order is this. And its degree is 1. Okay. So that's how you can, there can be questions, find out the order and degree of this differential equation. Now you can practice and you can.
One question like this will come.
Okay.
Order and
So you take a picture, then we go to the next. So what is order and what is degree, and where degree cannot be defined. So if it is not in the form of a polynomial, when you write like sine of dy by dx, then it is not easy to find the degree. The degree of the differential equation cannot be found out. Okay. So now we have understood what is a differential equation, what are the order of what are the order and degree of equation. So now general and particular solution of a differential equation. So we'll get into general and particular solution of a differential equation. Okay, let us try to find out. So let us say verify that the function e to the power minus 3x is a solution of the differential equation this. Okay. So this, let us do a numerical with help of that we will understand. Okay. So let us say y is equal to e to the power minus 3x. I am not deriving, I am just checking. Okay. So y is equal to minus 3x and my differential equation is d square y by dx square plus dy by dx minus 6y is equal to 0.
Substitute that in this.
Yeah. So, so the question is verify that y is equal to minus 3x is a solution of this differential equation.
Okay.
So if you put if you find the derivative and put in this equation, and if the LHS is equal to RHS,
That means it is a solution.
that means it is a solution. Okay, but that is a particular solution. There is difference between a particular solution and a general solution.
Oh, yeah.
There can be set of solutions. So if you are able to generalize it, then it is called a general solution. But there can be a particular solution. So in this case, it is a particular solution. So here, if y is equal to minus 3x, so my dy by dx is equal to, so I know it will be minus 3 into
3
x
power minus 3x.
minus 3 into e to the power minus 3x, right?
Yeah.
That is the first derivative, right? Then this, that the formula you have to remember. That's why I am telling why it is important to remember formula.
9 e power.
So minus 3 into minus 3 again, then e to the power minus 3x. This becomes 9 e to the power minus 3x. So this is your second derivative.
You have to substitute that.
And then you know your dy by dx is this. So if you substitute,
you get 0.
So what you will get, like minus 3 dy by dx, sorry, 9 e to the power minus 3x is the first term. Minus 3 e to the power minus 3x is the second term.
Then 9.
Minus 6 e to the power minus 3x. So this becomes 9, it cancels out, it becomes 0. So 0 is equal to 0, LHS is equal to RHS. That means this is a particular solution. Okay. So there are, you have some exercise based on this.
Okay. On particular.
You to just, there are questions that find out, verify that this y is equal to this.
So particular solution.
Particular solution. There you just want to verify. Okay. They will give a equation. So
Find,
that it.
You have to do differentiation and substitute.
Yeah. So that it satisfies the differential equation.
Okay.
So they will give y as a function of x. Then so that it satisfies the differential equation. You do the derivatives, replace the values, and you get it. Okay. So formation of differential equation whose general solution is given. So we'll do some, yes. Let us write a equation of a circle. Okay. So we have done circle. Okay. X square plus y square plus 2x minus 4y plus 4 is equal to 0. So how do you know it is equation of circle? Because it contains y square. Okay. So you now put x square and 2x together and y square minus 4y together. Okay. So then put this as 4 is equal to 0. Okay. So when you write like this, you can write it as x minus 1 whole square, because it becomes x square plus 1 minus 2x. Minus 2x. So minus 2 into x into minus 1. That becomes 2x. So what we have done, we have just additionally added 1 to it. So let us subtract 1. Right? Then y minus 2 whole square, let us write it like this. Okay. So this becomes y square minus 4y. Okay. Now I have added additionally 4 here. Because so I'll have to subtract 4 from here. Okay. So if I do like this, then this equal to 0. So if I write it in the form of a equation of a circle, x y minus 2 whole square and
that 4 is also there.
Right.
So that will get cancelled. This 1 will go that side. Is equal to 1.
Is equal to 1. So this is a. So that means circle general equation is x minus h whole square y minus k whole square is equal to r square. So the coordinate of the center here is h and k are nothing but 1 and 2. 1 and 2. And your radius 1 is radius is 1. Okay, so this is a circle with radius 1 and center 1, 2. Okay. So if you differentiate the equation 1, okay, you have this equation, so you try to differentiate it. So you differentiate the equation, differentiating equation 1 with respect to x. Dy by dx. So what is the derivation of x square with respect to 1 is fine. Okay, so if you derive this differentiating equation with respect to x, so for example, if you derive it, you will get the answer as dy by dx is equal to x plus 1 by 2 minus y. Okay. Okay. So this will be the differentiation where y is not equal to 2. So which is, so differentiating, so if you derive the equation 1, this is the answer. Okay. Which is a differential equation. you will find later in this that this equation represents family of circles. So this differential equation, okay, you will find later that this equation represents family of circles and one member of the family is circular. So this equation is, so this is a particular solution of this. Okay, this is what we have got is we have a circle. Okay, so we have a circle with radius 1, okay, and with center 1 2. Okay, so this is one particular circle, but this differential equation is equation of a family of circles. Okay, so this is equation of a family of circle and one member of, so okay, so there can be like family of circles. Okay, there can be family of circles. So this family of circles, like say inside one is now our x square plus y square is equal to r square. Okay, so let us say x square plus y square is equal to 1. Okay, this is one this is a circle with radius 1. Okay, then we can have a circle with radius 2. X square plus y square is equal to 4. X square plus y square is equal to 9.
Understood.
So
We'll have same.
so the differential equation represents a family of circles.
They'll have the same center.
But that equation 1 is one circle.
Yeah.
Okay. Similarly, you can find a family of straight lines and all that, and also
Means that equation is unique to a circle. This
yeah.
one will represent something with
the
common
differential
center.
equation represents a
Family of circles means something with common center.
Common.
Okay.
So that is about circle.
Straight line slope must be same. That must be the common thing. Okay, understood.
So
Wait, I'll take picture.
yeah. Okay. So that means this differential equation, it represents the family of cogs. Okay. Whereas
One equation represents something common,
yeah.
unique to one.
Yeah. Then let us do one, like we have solved the circle. Let us there is a numerical sum from the differential equation representing family of ellipses. Okay. So now we have done family of circles. So now there is a question from the differential equation representing family of ellipses having foci on x-axis and center at origin. Okay. So let us say this is one ellipse. Okay, so this is another ellipse. Okay, so you have family of ellipses. Okay, so you have family of ellipses. Okay, sorry, you have family of ellipses. Okay, just see. So you have family of ellipses from the differential equation representing family of form the differential equation. So a differential equation represents a family of ellipses. Okay, and a particular equation of that ellipse which is not differential equation, that will be a particular solution of it.
Understood.
Differential equation is a generalized one and its solution is a particular solution which is one ellipse, right?
Understood.
So yeah, so we know, like let us say this is my major axis, this is my minor axis. Okay, and the equation of a ellipse is x square by a square plus y square by b square is equal to 1, right?
Yeah.
This is then differentiating equation 1 with respect to x. So if I differentiate it, 2x by a square, right? A square remains same, that is the constant. Okay, then 1 by b square. Then we have to apply chain rule here. Okay.
Yeah.
Yeah. So it becomes when 1 by dx, okay, y square, okay, that's what it is, okay. So we will have to make it d dy by y square into d. So when there is a chain rule, like say f is a function of
u and u is a function of x.
So in this case, first what you have to do, like say, yeah, okay. So this becomes equal to dy dx is equal to 0, right? Sorry. Okay. So d by dx of y square, and then this is equal to 0. So this become 2x by a square. Okay. Then 1 by b square. Then what you have to do? You have to apply chain rule. D by dy into, sorry, dy square into dy by dx. Understood, na?
Yeah.
First you
I understood.
Here you have to apply chain rule.
Yeah.
Dy by, so in the previous equation we are getting confused. There are also chain rule. By chain rule you can find it.
Understood.
So in differentiation I have told you about chain rule.
Yeah.
So you directly cannot d by dx of y square you cannot do.
Yeah.
So first you have to do d
You have to
by
apply chain
dy
rule
of
and
y,
then do that.
y square, then dy by dx.
Okay.
So this becomes kind of is equal to 0. That means 2x by a square plus 1 by b square into 2y into dy by dx is equal to 0. Okay.
Yeah.
So this is my differential equation. Okay. Differentiating one with respect to this is for the first derivative. Okay. So then again you can, so this equation will get simplified to y by x into dy by dx. Okay. Dy by dx is equal to minus b square by a square. Okay. So then you can differentiate this equation one more time. Okay. If you differentiate it one more time, so this will be resulting in xy d square y by d square. Just apply chain rule and find out. Okay?
Yeah.
Xy d square y d square, then plus x dy by dx whole square. Okay. Minus y dy by dx is equal to 0. So this is the which is the required differential equation. Okay. So in the previous one you had b, a and all. Now you have eliminated those constants completely.
Yeah.
So after eliminating all those constants, whatever you are getting, that is your kind of. So what is the general differential equation after you eliminate all the constant? Like in the previous one we have eliminated all the constant and we have got dy by dx is equal to x plus 1. Okay.
Understood.
So take a picture of this. See, this is for ellipse. Earlier for circle we have not derived it. Let us derive. Okay. So x square plus y square earlier for circle we have done it plus 2x minus 4y plus 4 is equal to 0. So d by dx of x square. Then you apply chain rule, okay? Dy y square into dy by dx, okay? And then 2 minus 4 dy by dx plus 0 is equal to 0. That means 2x plus 2y into dy by dx.
Into 2x and all. Y into 2x. 2y into, because dy by dx, okay, no, that is, you have to take commonly.
Plus 2 minus 4 dy by dx is equal to 0. Okay, so this equation can be simplified as
Eventually, you have to find dy by dx. So you take that to RHS.
yeah. So you take 2y minus 4 into dy by dx, okay, is equal to minus 2 into x plus 1, right?
Yeah.
Right. So that means dy by dx is equal to dy by dx is equal to minus 2 into x plus 1 divided minus 2 into x plus 1 divided by 2 into y minus 2, or 2 to cancels out, minus x plus 1 by y minus 2, right?
Understood.
Okay. So this is
How to find
how to
general
find out a general
This also
differential
one question will
equation
come.
from a particular solution. Let us say equation of a circle, equation of a ellipse. From a particular solution, how to get the differential equation.
This will also come.
This will also come. Okay. So this is, so you know how important is the chain rule now. Okay.
Yeah.
The chain rule is very, very important. Okay. Okay. So now the next session is next one is methods of solving first order first degree differential equation. Okay, solving first order first degree differential equation. So if first order first degree differential equation is f(x,y), this is the representing a first order. Why first order? Because first derivative, and it has a power 1. That's why it is a first order first degree differential equation. Yeah, so the most generalized form of it is dy by dx is equal to h, y, one function h, and gx. Okay, so this is my differential equation. Okay. Then I can take y this side, dy by 1 by hy. Okay. Then gx dx, right? So once I do like this, I can take integration of both sides. I can take integration of both sides. So then finally it will become function of y, hy is equal to capital Gx plus some constant.
Understood.
This is the solution of a first order first degree differential equation, and there are many numericals here, practice numerical here, you can practice. Okay. So you will mostly at your level up to first order first degree is enough. Okay. So let us say one numerical dy by dx is equal to x plus 1 divided by 2 minus y. Okay. So then what I have to do here, like I'll say 2 minus y into dy is equal to x plus 1 into dx. Right? Now I'll start integrating both sides. So using the integration formula, I'll come up with a general solution of this. Okay. So by using integration formula, finally you will arrive at x square plus y square plus 2x minus 4y plus c is equal to 0. So this is the solution. So this is how you have solved first order first degree differential equation.
Understood.
Okay, so there are a good number of examples here. Okay, there are good number of examples here. which you can solve. Almost some 20 examples are there. Okay. So how do we use this? So take a picture of this. Then we will discuss how do we use this differential equation concept in practical life. Let us say in banking, how do we use it? Okay. How do we use the concept of differential equation in banking? Okay, one numerical we can solve. Okay. So in a bank, principal increases continuously at a rate of 5% per year. Okay, and in how many years rupees 1000 will double itself. Okay, so you have principal as rupees 1000. Okay, okay.
Yeah.
And your rate of interest R is 5%. Okay, 5%. Okay, so the question is how many year it will take? Year it will take to get doubled. That's the question. So how do we solve it? Okay. So here principal, let P be the principal at any time T. So uh, let us say principal at any time. So let us not give any notation to it. Let at any time T, your principal is P.
Okay.
Okay. So it is like a compounding interest. The principal does not remain constant.
It changes.
It changes. Yeah, it changes
With
like
each year.
so. There is something called like continuous compounding or monthly compounding. Suppose you are giving some loan. Okay, if you are doing it compounding, some banks will do it every month. They will compound it. Suppose you have taken 1000 rupees. What will be the monthly interest of that? That
will
interest
change
will
in
get
month.
added to the principal, and
Every
after
month.
the end of 1 month, it will become again the principal. So principal is not constant here. Principal is varying.
Yeah.
Okay. So
Means
principal is
that varied principal will become next month's principal.
second month that additional interest will get added to the
And
initial
become the new
principal.
principal.
New principal. So that's why a principal is a varying value. It is not a constant value. That's why you are telling like say at any time t my principal is p. So that's why I have removed that p notations from there because it is not a constant. Okay. So according to the given problem, dp by dt is equal to 5 by 100, like 5%, okay, into p. Okay. So if I multiply, so rate of change of principal, okay, is nothing but my rate of interest. So dp by dt is equal to
how much
principal
your
into
principal is changing is the rate of interest.
so so the rate of principal at any time. So according to the given problem, dp by dt is equal to p into 5 by p into 5 by 100. Okay. So with respect to time, how the
much your
principal
principal
changes.
changes.
So that is dp by dt.
That is your rate of interest.
So this becomes dp by dt is equal to my p by 20, right? P by 20. So it is nothing but you can think of a curve. This is nothing. Like say my time is t here, my p is this here. So how my principal changes is nothing but my rate of interest. That's why it's called a rate. It's rate. Okay. It's rate with respect to principal. Okay. So here dp by dt is p by 20. So your p is a function of time. All that we are telling is p is a function of time. Like you have done in your motion. Okay, your motion. Like say s is equal to ut plus half at square. Okay, that is the distance covered. Okay, so ds by dt is nothing but your velocity, right? Similarly, v is equal to u plus at. Okay, then dv by dt is nothing but your acceleration. Okay, so so that my distance, how does it vary with the time? Okay, so
Linear
can,
motion.
it can be anything. Okay, it can be a linear motion or
Yeah, it depends.
so it will be a curve, any type of curve. So the slope of that curve, so slope of the distance and time curve is nothing but your velocity. Slope of the velocity and time curve is nothing but your acceleration. Okay. So in this case, your principal is a function of time. Okay. So dp by dt in this case is equal to p by 20. So you can bring the p to the other side. dp by p is equal to dt by 20. Okay, so this. So now comes how to solve this first order, first degree differential equation.
By
Okay.
that.
Yeah. By integrating, so it is log p, dp by p is nothing but your log p, and then t by 20, right?
Yeah.
This becomes t by 20 plus c, right?
Yeah.
Then p is equal to, so if you solve it, p is equal to e t by 20, okay, minus e to the power c1, right?
Yeah.
This is
antilog.
Antilog. E to the power c1. Then p is equal to c e t to the power 20. Okay, so this is principal at any point of time. Okay, p is equal to c into e into t to the power 20, where and this capital C is nothing but your e to the power c. So that is also a constant. So your p is equal to c e to the power 20.
Yeah.
So at when t is equal to 0, when t is equal to when t is equal to 0, p is equal to 1000. Okay. So substituting the value of p and t in equation, we get this is your general equation. So you know when t is equal to 0, p is equal to 1000. So if you replace it, you will get the value of capital C. So once you get the value of capital C, the capital C will be 1000. Okay. So at t is equal to 0, p is equal to 1000. Okay. So if you replace it in this equation, you will get capital C. Once you get capital C, you can get the generalized equation, which is p is equal to 1000 into e t by 20. Okay. So now at any point of time you can find your principal.
Yeah.
So you will find in net banking application some loan calculator. So they may be using this equation. Okay. So now you can see.
It depends on what their interest is. Here, this much interest means this equation.
You can see now how important is the concept of differential equation and solving differential equation, and this is solving a first order, first degree differential equation.
Understood.
Okay, take a picture of this. So now you understand, like they have mentioned, it is used in economics, it is used in geology, anyway it is used usually in engineering, mechanics, and many other places, this differential equation. Okay, then there is something they are talking about homogeneous differential equation. Okay. Homogeneous. Okay, so if a equation is of the form f lambda x lambda y is equal to lambda to the power n fxy, then that equation is called a homogeneous equation. Okay. lambda is non-zero. So that's the definition of a homogeneous equation. Okay. So there are some numericals like say prove that it is a homogeneous equation.
That will be more. That will be LHS equal to RH.
So like say dy by dx. Okay. So they will say prove that this equation is a homogeneous equation. How do we prove? So dy by dx is equal to x plus 2y divided by x minus y. Okay. Then you take integration and finally you will find fxy is equal to x plus 2y divided by x minus y. Okay. So f lambda x lambda y is equal to lambda into x plus 2y divided by lambda into x minus y. Okay. Now this becomes
X plus 2y by.
lambda to the power 0 f x y. So this satisfies this.
Okay.
This is satisfying this. So that's why it's a homogeneous equation. So it is a function. This term is a function of x and y. Okay, and you have multiplied a lambda here. So lambda at the top. So lambda. So lambda to the power 0. Okay.
Yeah.
So f lambda x lambda y is lambda to the power 0 f x y. That's why it is a homogeneous equation.
Yeah.
Okay. Otherwise dy by dx you can write it as 1 plus 2y by x, okay, divided by 1 minus y by x. Okay. You can write this equation as this, and this becomes g y by x. Okay, so this becomes dy by dx is equal to g y by x. Okay. So RHS of differential equation is, so it is a homogeneous equation. It is of the form g y by x. So dy by dx is equal to g y by x. So that's why it is a homogeneous differential equation. I don't think there will be questions on this.
Because it is proving thing.
Okay, so that's fine. So no need actually.
That general equation and order degree is what we learn.
Yeah. And so now you understand what is homogeneous. Then this. And then linear differential equation. So dy, so linear differential equation. So the linear differential equation is of the form dy by dx plus py is equal to q. Okay. So where p and q are constant. If this is the case, then it is a linear differential equation. Like why it is? Because it is the form of y is equal to mx plus c or whatever in that form. So this is called first order linear differential equation because this is first order. Okay, first order linear differential. So some examples of first order linear differential equations are dy by dx plus y is equal to sin x. Okay, this is one example.
Okay.
So these are constant or functions of x only. Not only constant, functions of x only. Okay, so here it is a function of x.
Yeah.
So if p and q are constants or functions of x, then it is linear differential equation. And then So there are other equations also, dy by dx, 1 by x into y is equal to ex. Okay. Then dy by dx y x log x is equal to 1 by x. These are all linear differential equations. Okay. So there are some numerical on how to find the solution of
Same
linear
general
differential
solution.
equation. So there are some examples here. Like say, let us say we have one example. If you solve one example, you will get to know. So dy by dx minus y is equal to cos x. Okay. So this is a linear differential equation, and yeah. So in this case, p is equal to minus 1, p is equal to minus 1, q is equal to cos x. Okay. Q is equal to cos x. So there is a they have derived actually. So actually there is a derivation. It is of a linear differential equation. They have derived and come to the final equation is e to the power integration minus p dx, okay, into integration q e to the power p dx, okay, and then whole thing into dx plus c. Okay. So this is the general solution of linear differential equation. So you can use this concept here. Okay. So now you know what is your p, what is your q. Knowing all this,
You can simplify.
you can simplify and do it. Okay. So there is a derivation of this. Finally, this what I have written. This is the final solution of a differential equation, linear differential equation. Now, what is a differential equation? So, equation of this form where p and q are either constant or a function of x. Then this satisfies this because dy by dx. So here you can see your p is 1 and q is cos x. Cos x, no?
There it is sin x, here it is cos x.
Okay. Okay, so yeah, so here it is cos x, here it is sin x. So now you know what is linear differential equation, and this is the solution, final solution which you remember, and then using this you can solve any linear differential equation. So I think that's it for in your U level. That's it on the differential equation.
General solution, order, degree. In boards we had that homogeneous solving.
Okay. So we have covered the complete differential equation. Now it is your time to practice as many as possible. Okay. See this order and homogeneous equation, linear differential equation, chain rule. These are some of the key things. Chain rule. Chain rule will be very important. Everywhere it will be applicable.
It's there in differential.
And also what I have taught you in the differentiation, like the addition and subtraction are very clear, but the multiplication, product and quotient differentiation you have to remember, because you won't have time to derive. There are in differentiation and equation you have to remember things. You don't have any time to derive that. So you have to have 2 sheets of formulas for differentiation and equation, and you have to by heart all those things. Okay, thank you.